Whoa, it is a crowd today. Holy shit.
That's it.
Yo, brother, what's up, Highlander? I think
What's up, dude?
we have a really good show for today. Highlander, do you have it? Are we recording now or are we good?
I think Mr. Camel's on the recording. Let him DM me and just confirm that. If not, I can run the Riverside.
Cool.
Give me one second. Yeah, he's recording, mate. You're all good.
Cool, sweet. So today we are going to be working on a dynamic NFT contract. Anyone familiar with dynamic NFTs? Any interest in dynamic NFTs? Maybe. All right. In the live coding chat, I'm going to just paste a couple of links. The first one is the repo we're working in. It is the Code and Chill repo. As we meet weekly to work on projects, we're going to just keep putting more and more stuff in here. The second thing I'm going to put in the chat is an amazing course or amazing tutorial on CosmWasm called Zero to Hero. It was built during the last hack Juno. And it's actually an amazing tutorial, and I recommend checking it out because it's wonderful. And if we're good to go, let's get started. Are we recording? I'm just gonna assume that we are, and if we're not,
you're recording, mate. All good.
You have to share though.
I'm gonna share right now. I practiced this yesterday, so cool. All right, we got some feedback last time that I should use a different coding editor because no one knew what the fuck was going on. So now I'm using VS Code, which is what everybody else uses. And as a result, I actually don't know how to use VS Code. So I might get confused, but I think that's good because maybe we can teach some people some tricks at the same. Feel free to chime in with questions. You can interrupt me. It's great. I like interruptions. And yeah. So this is a CosmWasm to Zero to Hero. I already pasted the link in the dev chat. You should really check it out. It covers like everything. And so if you go through this, you're going to be a really good CosmWasm dev. It also has a lot of other great articles that you can link to and read through. So if you want to study on your own time and you want to get extra credit and you want to get accepted into Elite Society and you want to get like a vested like Juno Dev grant and access to really cool opportunities, then maybe you want to go through CosmWasm Zero to Hero. But the main thing we're working on today is this Juno Code and Chills project. The one we're working on is called CW Piggy Bank. It is a piggy bank contract right now. We're gonna be improving it a little bit today. We're gonna make it into a dynamic NFT contract. So the more money you put in the piggy bank, it's gonna gradually change the appearance of the NFT so that, you know, it's dynamic. We'll talk a little bit more about dynamic NFTs in a bit, but we have some new technology now. So if you go to the contract, I'll actually just also paste this link in live coding chat. You see this open in Gitpod thing? If you click on this, it'll actually open up a workspace in either the browser or you can also use your VS Code desktop. And the cool thing about this is running in the cloud with all the dependencies and everything set up for you. So if you're on Windows and you don't know how to install Rust, but you just want to get started coding, just go to the link I just pasted in the chat, this little guy here, and then click on this open in Gitpod. You might need to like sign in with GitHub, but it works great. So like here, we've just opened up the file. We got our contracts files in here. So this is all the code we wrote over the last 2 weeks. Everything's in here and it's already set up a whole working workspace for us with all the dependencies we need and everything's just good to go and it's installing everything. It's great. This is the technology of the future. You don't have... So if you've struggled to get like a Rust environment set up, please give this a try. And in fact, I'm going to make this workspace shareable so that anyone who wants to can actually live code alongside me. It's probably going to be chaos, but I like a little bit of chaos. If you want to just, I'll actually paste the link for it right now. Share running workspace. All right. This is probably going to go really crazy, but we'll see. So just pasted the link to it in the chat. Oh, I see people are already editing files. All right, go to town. It might be chaos. If you want though, just go to your own repo and start your own workspace. And then you don't have to worry about other people writing over you. But yeah, this is a great place to go in and play along. And as you can see, we got like our little terminal down here. It's basically just running our tests over and over again. And then you can just, yeah, everything's set up so you can go do that. I'm gonna head back over to VS Code. So this is just running on my local computer. Let's talk about a little bit about what we want to do today. I wrote some notes a little bit earlier about dynamic NFTs. Let me just find those real quick. Let's see. Yeah, the GitPod stuff is really cool. And we're going to try to use that with all our projects. And eventually, as we go forward with Code and Chill, you can expect that basically everything's going to have a GitPod. Even the stuff that's going to do like on-chain or indexer stuff. And that'll just make it really easy for you to come in, get started without having to worry about like a whole bunch of setup. All right, so I just pasted some notes into this README. I'm going to commit them in 2 seconds and you'll be able to sync it. So when we think of dynamic NFTs, does anything come to mind for people? Can you think of a good example of dynamic NFTs that you've seen in the wild?
I've not seen anything in like upfront yet, but could a dynamic NFT become where, let's say you have a ticket for an event and a ticket tout wants to try and sell the ticket on for more money than its retail value? Does that become a dynamic NFT?
No, I think that's just a normal NFT. I think that's what everyone wants to do with NFTs is they want to buy them and sell them for more value than they originally bought them for.
Yeah.
What if you wanted to upgrade your ticket to VIP from just general admission?
That could be a more dynamic NFT for sure. I think more like imagine, let's use the example of a game. So we just Googled on Wikipedia and this is what we got. So dynamic NFTs, also known as DNFTs, are a new generation of non-fungible tokens that include programmable and interactive features, allowing the creation of digital items that can change. So I think this is the key thing is that like normally when we buy NFTs, they're all just static, right? They just always stay the same. But these are NFTs that can like change and evolve over time. So basically you can create like a more engaging experience for buyers and fans. So what if you had like I think game items are actually really good for this. So say you have a character in a game or whatever, and as you level up, your character like takes on a slightly different appearance, or as you get damaged or run out of health, it might take on a slightly different appearance. Or maybe you have some item in a game, and I don't know if any of you have played like the Witcher games or whatever, but they're pretty popular. And a friend was telling me about them. And they have this whole like crafting system, right? So if you get a sword, you can put like jewels in your sword to, give it like extra power-ups or whatever. You can imagine a bunch of kind of use cases for these. We're going to create, I think today, a really simple one. And there's also many different ways we can go about achieving this functionality, but we're going to go for a pretty simple one today. Let me make this bigger. If this font size is too small for people, let me know and I will make it even bigger than this, but I feel like this is really big. So first of all, there's a couple of different ways that we can make dynamic NFTs. And we're going to just focus on one today, which I think is pretty simple and very flexible. And in reality, there's a lot of trade-offs to each of these approaches. I won't say there's one right way to do it, even the way we're going to do it today. So the first way we can do a dynamic NFT is basically have an approved account that's allowed to update the token URI for a token. So each NFT, all NFTs have a token URI that is what actually links to the metadata. So if we actually find like dynamic NFTs GitHub, this is actually like the most common approach. Let me just find one real quick. I'm pretty sure this is going to be one of these. If we go to this contract, they got a lot of stuff with like levels and like mana energy counts and stuff like that. And I bet if we scroll down, yep, here it is. This is how most people do dynamic NFTs. So you see the set token URI solidity function. We're not going to write solidity today. Don't worry. It's bad. But basically they're just checking that this is an approved owner, and then they just manually set it. So that's like that's a valid way to do dynamic NFTs, is basically just have an approved account that's allowed to like go in and manually set stuff, like change stuff. And this works. It really does. However, to make good UX around this, you need like indexers and like bots, but you can make this work, and it's pretty easy to do. And we could talk about how we would do this one really quick. The other one is another very valid approach, is you can actually construct the metadata and images in the contract, which is like the least gas efficient, but you do see this a couple times, especially with SVG based NFTs. But you have to be really good with like SVGs to make that work. Another approach that's valid, albeit maybe not the most decentralized, is basically using a backend server. So instead of linking to a file on IPFS, you would link to a like backend server with the token ID, and then the backend server would return a different image based on whatever the status is. I don't like this approach because it's not very decentralized. However, you could create pretty powerful experiences with that. Another one that's like really popular in a lot of collections, the awesome Pixel Wizards collection on Stargaze, one of my favorite collections actually, because if we look at Pixel Wizards, let's look at what's happening. This is not the only NFT do this, but it's another common approach where basically you write a front end, you basically write a little mini website that handles the image generation based on chain metadata. This approach is great. It's very decentralized. You can actually upload this little HTML file to IPFS, and so it's very decentralized. However, the risk here is that it has to run in an iframe and might not display correctly in all wallets. Let me just show you an example of this. So so here's Pixel Wizards. Waiting for it to load. If we just look at this guy, for example, wow, this guy looks awesome, great. And if we inspect element here, so you're probably wondering, like, how did they get this to move like this? Is this a GIF? Like, what kind of black magic are they using here? And if we look over here, notice you see on the side here, let me just make this a little bit bigger. We got this iframe. So this is basically an HTML file that's running inside of an iframe, okay? And it actually is stored on IPFS. So as you can see, this is actually an IPFS file, and it's just a little HTML file. So you can think of this as like a mini website. And this mini website can be super, super dynamic, and it's a good way to go. I really recommend this approach. This is probably like the most like powerful approach for making dynamic NFTs. But a lot of the art a lot of it really comes down to basically like front end code and JavaScript. And today we're going to be very focused on smart contracts. But I did want to mention it because I think it's a very valid approach. And so we can actually see here that this is an IPFS file. So we go here. Voila, we've got our Pixel Wizard in huge HD kind of glory. Amazing. And there's a bunch of NFT projects that do this because it is probably the most flexible way of creating dynamic NFTs at the moment. We're going to do another approach though. So the last one is, which is I think the one we're really going to explore today, is to update the token URI in the contract based on chain events. So for us, this is going to be like when someone deposits money. And eventually we're going to turn this into a game that we can all play and have a lot of fun with, hopefully. But the example I want to use today for our little use case is NF trees, basically, or NFT trees. And so basically imagine a tree. So we already have this piggy bank contract, right? As you deposit money in, like it grows in value. The only way to get the money out is to burn it. And so we could basically do this with NFT trees. So we have these trees. When you first mint it, it comes as a little seedling. And then as you put in some more carbon credits and you lock them up, it grows into a sapling. And you put in more, it becomes a tree. And you put in more, it becomes a really big tree. And then you put in up to a certain amount and it becomes like the biggest tree. It reaches its fully formed final stage. So that's what we're going to be building today. And how do we do this? So the first thing we have to really think about is actually the folder structure for our metadata. when we upload it to IPFS. And there's some really great tools that we're going to also cover today. Pinata is a good one. Pinata Cloud, yeah. Yeah, so Pinata is a really great, they use IPFS under the hood, but they have a lot of really great like NFT storage tools. Another one I really like is NFT storage. This one. So these are two really great websites. I actually will also post in the links. If you're looking for an easy way to store stuff on IPFS so that it's stored in a decentralized fashion, this is a really great way to do. And as you can see, it's used by lots of really great projects already. And they have pretty good docs and stuff. So I'll let you look at that. But yeah, if you're looking for, also if you happen to make an NFT collection or mint an NFT on DAO, it uses NFT storage under the hood. It's pretty cool. You should definitely check it out. Pinata is also another alternative that is also really good. Pinata tends to have a bit more features, which is great. So yeah, let's use this example of a tree that grows the more we feed it with carbon credits. When we upload this to the cloud, actually, let me just push this so we can look at it on GitHub, and then it'll be like pretty formatted. So I'm going to add this to the Git file, or just, I'm going to commit this. Bear with me. I have not used VS Code and I get really confused. And then I'm just going to open up a terminal. I'm going to git push origin main. I'm just going to push the code to GitHub. So sometimes when you're working with Git, you get into a problem like this, where you can't push your branch because there's changes upstream. I forgot I made some changes upstream. I'm going to do a rebase. We could talk about this. We can talk about this later. It's probably off topic, so I'm just going to do it.
Yeah, it gets me every time.
Usually you can try this, git pull -- rebase origin main. There's probably a way to do it with the UI. I actually don't know. But yeah, so that worked. Now I can push it and it'll work. It'll work great. That was awesome. So what rebasing does is it basically takes all the changes upstreams and it takes all the changes I made and it rebases them. It changes the order and then I get no conflicts. Amazing. So let's look at that README file we just wrote so we can finish this up and keep going. I want to make this one a little bit shorter than some of the other ones, just if only for like good video content. Y'all are welcome to hang out and chat for as long as you want afterwards. So yeah, we got our dynamic NFT functionality. So we're going to use this example of trees. Basically, because we're basically going to just swap out the token URIs, it's really important how we lay out the folder structure for all our NFT metadata and images. Here's an example of basically how we're going to do this. So we're going to have, this is our metadata folder. This is the folder we're going to basically like upload to IPFS via like Pinata or NFT storage. It doesn't really matter. That will contain many different other folders in it. So you'll have the top level folder, which we're just going to upload. And then it'll have folders for each token ID. So 1, 2, 3, etc. And then for each token ID, we have like basically 4 different states, right? So we have seedling, we have sapling, we have tree, and we have full grown NFT. And so each one of these is going to have a slightly different, definitely going to have a different image. It might have a different name. It might have a different description. So yeah, that's basically how it's going to work. And then, so the folders are the token ID, and inside of those are the possible states of each token. And the entire metadata folder, we're going to upload this to IPFS. And when these NFTs are minted, they're going to have the initial like seedling state, if that makes sense. Now, as more funds are deposited in the NFT, and we're going to just do this now, we'll have logic to update the token URI accordingly. For example, when 1 token has been deposited, we update the token URI to sapling. Like so of, oh no, I don't know what that is. Yeah, make it a little bit bigger. Oh yeah, so when 1 token has been updated, we're going to update the token URI to basically our base IPFS hash, which is going to be the hash of this folder. And then we're going to have the token URI ID, which is going to be 1. And then we're going to have the actual metadata for the NFT in that state. I hope this is making sense to people. It's not too complicated, actually. but it's really important that our folder structure matches the logic of the contract. So basically when 10 tokens have been deposited, we're going to update it to the next state, right? Tree. And then when 100 tokens have been deposited, we update it to full grown. And I think it's just really important to know that for this type of dynamic NFT to work, our metadata and the way we structure this folder and the contract, the logic of the contract very much have to be in sync. Otherwise, we could get to a point where we might actually have a broken image on our NFTs. But yeah, any questions up until this point, and they could be like even more about general stuff, and tell me if I'm like going way too fast. And maybe I am, but we've also been doing this for 2 weeks now. I do see like a lot of new people. But yeah, any questions so far? All right, no questions. Let's go. Let's just do it. All right. Get rid of this. So we've got in our code and show repo, we have our contracts folder, and in the contracts folder, we have CW721 piggy bank. Our entire contract is in this lib.rs file. Now, if someone wants to volunteer, I think this would be a really great thing that you can start experimenting on the side. Keep in mind, you can come in here and you can actually use this Git pod link and make changes in real time. And I think anyone with the link can actually do. I already pasted it in the live coding chat, so feel free to give it a try. You'll be able to like make changes in real time and yeah, have fun. Feel free to play along. So yeah, this is our contract we've been writing over the week. We even have a bunch of tests in it. Something that you might want to try doing as a little bit of homework is to maybe start breaking this big file up into multiple files. I think that it's starting to get a little bit big now, and it's going to be even bigger after today. So I'm not going to do that, but if you're looking for some homework, that would be really helpful. And if you make a successful PR against this repo, you will get accepted to Elite Society. That's some incentive. All right, so let's talk about like how we're going to do this. So in the README, I talked about the really simple thing that almost everyone does is they just have the manual way. So I'm going to show you how we could do that real quick. So we have our execute extension where we're building off the base NFT contract, and therefore we're basically inheriting all the basic NFT logic. This means we don't have to implement like spending an NFT or transferring an NFT. We just have to build the logic that matters for our contract. So we already have this custom deposit method. We could make another one that's basically update token URI, and we could have that would basically take a token ID, which would be the token we're going to update, and then the new token URI. Then we would come down here to our execute method. Here in the execute method, again, every CosmWasm smart contract has 3 main pieces you have to know about. Instantiate, they're called entry points. So these are how the blockchain like interacts with the smart contract. So the first one is instantiate. That's the initial message that sets the initial state of the contract. The second one is execute, which is this is what changes the state of the contract. This is how you do things. And then lastly, we have the query, which is basically the read-only version of the contract. Like basically, if we wanted to implement this update token URI, we could come in here and in our execute extension. So obviously you can see we've already overridden some default behavior. And here we can implement our custom behavior. It's a little bit funky, but I'm still learning how to use VS Code. So we're just going to leave that unimplemented for now. So we basically we'd go through and we're going to pass this off to a handler function. Let's do that. So we're going to do execute update token URI. It is going to take the token ID, right? And we're going to take a token URI, which is a string. And then we're going to do a default response for now. We'll come back. So here I've got this unimplemented. I'm going to swap this out with our new execute update token URI function. Boom. Okay, so now in this execute update token URI function, we're going to want to check that I've talked about this previously, but usually when you write smart contracts, half the thing is you want to do a bunch of validation and checks, and a lot of it's thinking about what needs to be checked. So here we need to check ownership, right? Actually, no, we don't want the owner of this. We only want like the minter or the admin. And the reason is maybe it's like this is the artist of the project, or you don't want, let's say it's bad kids or something. You don't want like anyone to just give themselves like the most rare bad kid, right? This is another thing I don't really like about this manual approach is it implies like a really trusted person or admin to be able to like dynamically update the NFT. But yeah, I think we can do it real quick. So first thing we're going to do here is we're going to, that's not fun. Okay. I'm still learning how to use VS Code. I'm very lost. So we're basically building everything on top of our base contract here. And the base contract has like a lot of like great functions that we can use. So if we look at this base, like you can see we've got access to all this really great stuff, which is pretty sick. And so this is like this is the default implementation. And so I think we're going to want to get the minter. Checking the chat for questions. And as you can see, we also get like nice little like type hints here. So we can see that this takes basically our storage dependencies and then it returns a result with a minter response. So that's cool. Now I'm going to save this. And as you can see, we've already got our first error. Now it's complaining that it expected dependencies, but it found a mutable reference. So Rust is very strict about whether or not, by default, all variables in Rust cannot be changed. They're immutable. They're immutable like the blockchain. And so this is, because this is basically a query, it's expecting an immutable reference, and we passed it a mutable reference. So we can actually fix this by not doing that. I'm so lost because this is not my normal like code completion stuff. And
You need to pass mute in somewhere.
see, these are depths mute. Let's actually, I'll show off another thing here. We'll resolve this.
I'm just loving how you're dealing with the debugging, man. It's great.
Yeah, we're all learning all the time. This is docs.rs. It has documentation for every Rust library, including all the CosmWasm stuff. It's really helpful. So if we actually go and we look at depths mute, so this is, how did I find this? It's right here. These are our dependencies. This has access to all like the API and everything that we need. And it has these fields and we can click storage here. And I swore there was a way to convert this to a non-mutable version. Oh, here we go. So storage provides read and write access to persistent storage. If you only want to provide read access, provide and storage. Okay, that should help us. Okay, let's try that. That doesn't like it. We're off to a really great code and show.
There was a little question in the chat there, Jake. If T needs 100 funds to get max, if we deposit 150, can the smart contract return the funds?
Great thing about smart contracts is they will do whatever we tell them to do. So if that's how you want it to work, yes, we could do that. In fact, we could do that now, but I'm just really annoyed by this. Why? Okay. You know what? I'm going to come back to that. So it's really hard working in an editor that I don't really know. And we're gonna do, this was a side tangent anyway. So we're gonna move on. I don't even know how to comment stuff out in VS Code. Oh my gosh. All right. But
If you highlight it and then go //
Oh, okay. Another thing that's a really good trick in Rust, if you have something that's like you want to just come back to later, you just throw in an unimplemented macro, and that will allow for things to compile without having to like finish actually implementing everything. This is very handy, especially when you're just mocking stuff out. But yeah, let's talk about how we want to handle it, because this was a side thing. I wanted to show you how you can do the manual way, which would basically be we would do a check. We would check the minter basically, And then we would, if that's okay, we would just update the token URI and save it. That's simple, really not rocket science. And we'll come back to it and I'll realize the very stupid thing I was doing. But for the other logic, let's take a look. So we have this, we're just going to assume this folder structure here. And basically, I think we're going to do, yeah, like when people deposit, we are going to update the token URI. Oh my gosh. Andre, you are a hero. Send me your Juno address. That was great. Oh, I'm such an idiot. Okay, I'll explain what was wrong and why I was doing something really stupid. So we're gonna load the minter. So we have our base contract and it has this little minter query function. I was trying to do deps.storage and then we need to take these dependencies right here as a reference. And then we need to do storage. There we go. Well done, Andre. Thank you so much. Appreciate the help in the chats. Oh, no, I think it just needs refs. Great. Okay, finally we did it. Oh, yes. Amazing. Okay, so now let's just write like a really simple check here. So info is a variable that comes with every message and it has all of the information about who sent the transaction, how much gas did they paid. So we're going to check that the info.sender is we're just going to check that they are the minter. And the minter response is going to be an option. So let's just take a look real quick here. So this is a minter response, and as you'll see, it is an option. So we need to handle this in Rust. Again, the great thing about Rust is they make you handle all the edge cases. So if I save this right now, it's going to throw some errors. And why is it throwing an error? It cannot compare an address with a minter response. So there's a couple ways we can do this. I'm just going to show you a simple way that you can use. It's called an if-let statement. This is basically a way to unwrap an option value in Rust really easily. And then we'll just save that. I think this will work. All right, so this is complaining that we don't have an unauthorized error in our contract. Let's come back up here. This is where it'd be really nice to break things up into separate files. So again, if someone wants to try some homework and get Elite Society invitation and maybe some other things, we have this base error contract here. Let's take a look at that. There is this ownership error thing. We could use that. But you know what? I'm lazy. So we're just going to put the unauthorized error in here. Why not? So we just added that to our custom contract errors. And if we come back down here, great. Now we've got no errors. So we basically have completed this little check here. Now, there's an obvious mistake here though. And I'm going to also let somebody find it. I'm going to leave it on screen. I'm going to actually move on. But if you can spot the error, you can also win some Juno. I'm gonna let you look for it. So now that we've supposedly checked that the minter is the sender, or that the sender has rights, let's update that token. Yeah. So, and I think it's really basically, let's do this. George, in Rust, can you only write smart contracts? You can actually use other languages, but Rust is best supported for CosmWasm. There is a team that's a good question. There's a team that is working, William Chen is working on making it so that you can write basically smart contracts in TypeScript. So that's something that might be available soon. It is possible to also write them in Go, but it's not like super well supported. Yes, Rust is probably the best way to write smart contracts as of this moment. And I'm sorry for being a little bit more confused than I normally am because I just don't have my editor. And I hate this. There we go. Oh my gosh. I'm so confused. Normally I use Linux. Sorry guys. That works. Actually I'm going to turn off this Copilot thing. I hate this. This is really annoying. I have to reload. Oh. Okay, that's better. It's just telling me a bunch of wrong stuff. Always be careful with that AI shit. Like it thinks it knows what it's doing and it looks like it could be right and then it's not, and then it's just wasting your time. So basically we've already checked. There is a bug here. No one's found it yet. But assuming we get this part, we check that the sender is authorized to update the token URI. Now we have to actually do it. So we can load the token right here because the base contract has all the storage for all the tokens. And that's just a normal kind of storage item like we've covered before in CW Storage Plus. So then we just do token.token URI, and we're just going to set it to the token URI we passed in. Boom. And now we just got to save it. Oh my gosh. All my keyboard shortcuts are wrong and I'm just sad. And then, okay, now we got a squiggly line. We can check it. And it says, consider borrowing here. One of the things I do like about Rust is it tells you exactly what is wrong and what to do about it. And now if we save it, boom, no errors, great. So we can actually get rid of, we actually implemented this. Even though there's a bug, I've still not seen someone, no one's found it yet. We're gonna leave it there. Maybe this will be homework. I'm not gonna give hints on the bug. Someone's just gotta find it. It's actually pretty obvious. Again, Rust is very type strict. So this function returns a result or a contract error, or it returns a result, which is a common Rust type. So a result is either a successful response or an error, which is a contract error. So we're going to just use the default response. I'm going to add a little bit. I'm going to add some attributes just for fun's sake, but also to maybe help like any indexers that might, be looking at on-chain data to update. So we're going to make this action update token URI. See, did someone fix it over here? Nope, no one fixed it over here. All right, okay, I'll give you a hint. This minter is an option type. Did we actually handle all the cases?
So you have to have the none case.
Correct. Yes. So we actually fucked up, right? And this is what you have to be careful for in smart contracts. A lot of the biggest smart contracts errors in Ethereum are always something like really stupid. If let sum here, we're handling the case if the minter is defined, but if there's no minter, we actually don't actually do any checks, right? And so what we actually want here is a match statement. And then we have to handle the none statement. So what happens if there's no value defined? The way it was written, if there was no actually admin or minter defined, it would have sadly allowed anyone to update the token URI, which would have been bad. Way to make your NFT collection worthless. I'm so upset with VS Code. Just don't know what I'm doing. Sick. Now we fix this. So this is a fully working thing that you could totally use for dynamic NFTs, albeit you would have to have some authorized bot or account that would manually go through and update things. Let's explore doing it the other way. And it's pretty similar. We're actually almost done here. So this code right now to update the token URI, like this is what we're going to basically use in the future. So let's just actually just copy it. We could even break it out into a function to make it a little bit nice and more reusable. Maybe we'll do that. Maybe not. I'm lazy. But here we've got our execute deposit function. The way this works is you basically just deposit money in the contract and it saves it. Great. Now we're already checking that. Yeah, so let's just do this right now. Let's load the token. We're already doing that here. We might need to refactor this because it's a closure, but let me just show you what happens. So what happens if we try to do token URI equals, oh yeah, that works, okay. Now we could do this. We only have a couple different states, right? We have seedling, sapling, tree, full grown. We could just actually just handle it with if else, right? So yeah, we got our new balance here, which is basically the previous balance of the token if it exists. That's why we're doing this unwrap or default here. The default would be 0 plus the amount that we're actually depositing into the token. And we already check that funds are sent, and we're checking also that the correct type of funds were sent. So if this contract takes Juno, we're checking that Juno is sent. And if it takes carbon credits, we just check that the right things that we are expected were sent. Oh, Andre's already got something. Oh, cool. All right, cool. Other people are working on this. I'm going to show you my stupid way of approaching it because it's pretty easy. So we got our new balance here, and this is going to be really dumb. You all are going to hate me. So we could just be like, if new balance greater than. Keep in mind that values in Cosmos blockchains for native tokens, and there are some slight edge cases here, but we'll cover those in a bit. They're usually basically they're always in micro units. So when you send someone Juno, if you ever use the command line tools, you'll see like basically the amounts in what are called UJuno or micro Juno. And so here, this is like equivalent to 1. They're like typically 6 decimal places. So this checks if the balance is greater than 1. I think I counted my zeros right. 1, 2, 3, 4, 5, 6. Yeah, great. And then, oh boy. Oh, VS Code. Where was I? Oh. And then we could do else if. This is really dumb, but this would totally work. And sometimes in smart contracts, we're dealing with a lot of crazy shit. Sometimes simple is good. It's nice and readable. Now we're going to do 10. So I just added an extra 0. Now we could implement like a limit. Let's say someone suggested earlier, if you send more than like the maximum amount, you get your money back. But maybe you just want to charge it up, right? Because the whole point of the piggy bank NFT is that the money is in the NFT. And so that inherently makes it more valuable, right? So maybe you just want to go extra. So basically, this is really it. We do need to do some string manipulation here, but I'm gonna hold off on that and just like finish the end part, which is basically now we just have to save our token. Cool. And great. So we've got like we've effectively made like a glorified switch statement here. Not the most advanced thing ever, but it's real. Let's find a tree and let's upload some metadata and try to see what this will look like. We might do some of this as homework. We've gone a little bit long, but yeah, this is the gist of it. So we've actually explored two methods for creating a dynamic NFT. But I think to really fully understand this, we have to like understand the folder structure and format, right? Because basically we'll have our base IPFS hash. And then we'll have the token ID, and then we'll have these like saplings basically. So we're going to actually have to do some string formatting here with Rust. And then we'll basically have that. So one of the things we could do is let's actually find a tree and upload it just to show you. I should have done this beforehand, but all right, great. Perfect. Oh yeah, you should all check out these tools actually. I think we might cover this point next time actually, because I really want to go through the process of like how do you organize all the files in the NFTs and things like that, and maybe it's something you guys could probably actually figure this out. Like it's a really good thing to explore. I'll walk you through it through a high level, and then I think we're going to take some questions, and then we'll just end for today. And then next time we will actually make this NFT trees project a thing. And maybe we can do it with like regen tokens or whatever. And then we'll start exploring making a game that's more fun, right? We want degenerate gambling games. Come on. God damn it. We want fighting games. We want games with collectibles and fun stuff. I don't know. We want board games. So we could do format strings in Rust. There's a format macro. So basically what we're going to want to do is like, we're going to have yes, of course we need a good play to earn game on Juno. And that's why we're going through the process of making dynamic NFTs and stuff. Because hopefully you can see that this might actually be like the basis of a potentially fun game. And while the trees might be lame, you can think of like a game where like monsters like eat each other. That might be more fun, right? Like you could have a last man standing kind of game. Yeah. So our I'm just going to jot down some notes here and then might even let someone else finish this. So we're going to have basically if we look at one of these URLs in NFT storage, again, the structure of the folder like is really going to matter a lot for the like this logic right here. So we're going to have a link. Mac is killing me. It's killing me. So we're going to have a link that looks a lot like this, right? So this is going to be like what I consider like the base URL. Like this is like the base URL. And then it's going to have the token ID. So this is going to be the token ID basically. I'll just write it literally. And then state.json, right? So that for us, that's going to be like sapling, etc. So then basically what we're going to want to do is we are going to want to, and we can even do this when we make the NFT. There's multiple ways to do this, but we're going to want to save this part. We're going to want to extract the base URL from it. So we're going to basically want to pop off the 2 items of the URL. And there's probably some good Rust URL manipulation things you could use for this. Play around with how you might implement like this functionality here. Hopefully it makes sense. But basically, you could also hard code it, but we wouldn't want to hard code it, right? Because we might want to use this multiple times. But I think that one of the problems with the approach we're doing right now is that it oftentimes is very hard coded because you have to know exactly what kind of metadata you're dealing with and the structure of it. So we could actually do it like this, where we might have a base and we could do, there's this format macro in Rust, which is pretty cool. Oh, no commas, slashes. There we go. Not be overly prescriptive about it. So let's take base URL or take token ID. And we're going to, so as you can see, what we did here was we have this format here. So we format the string with the base URL, right? And slash, okay. And then we have the token ID. And then we set it to the sapling state. So we're just going to do this again and again. And we've created a dynamic NFT contract, assuming that this is just some random thing, but assuming that it actually matched the folder structure, this would work absolutely great. And it's really simple. And so then we would do tree and full grown. And voila, that's like, we've just made a dynamic NFT, guys. That's great. So I'm going to leave some homework there for you. I'll push this code and then you can play around with it. And yeah. So yeah, that's it. But it's pretty, so we've actually done 2 ways that you could do dynamic NFTs. So I hope that helps. And now this contract we can accept money. You can fill up all the NFTs with money. We have an example for how to get the money out of the NFTs, which right now is burning, but you could think of other things, like maybe you could have like monsters eat each other, right? Or you could figure out other conditions by which that the funds that are locked in the NFTs might get released. And yeah, we've got 2 ways to update NFTs, which is sick. So yeah, any questions? Everyone's just speechless. It's been a lot of me talking, for sure. Wow, no questions. It can be about anything. There's no dumb questions, guys. It can even be like, what are some general tips for whatever?
So it's not a question, but for the sapling tree JSON part that you hard coded, could that be an enum instead?
It'd totally be an enum. That actually would be that'd be a nicer way of doing it. Really, I've just done it in like the most hacky way possible. But yeah, enum could be a lot nicer for sure. And if you had, let's say you had I would definitely recommend enum if you had a more complex kind of like game thing, right? So if you have a game where it's like there's many different types of states and they're a lot more interrelated. Like right now, there's only one deposit function, right? And so this is just very straightforward. And we could have an enum, but I'm not sure how much more value an enum would add for such a simple thing. But if you can imagine a game where, let's say these values were used in many different places. So let's say this was a character and one of these states was dead and then there were multiple ways to die and you wanted to like, then I would definitely use an enum because you wouldn't want to trust yourself to write the right thing in more than one places. You would
just want to have it in.
Yeah. So you could definitely do this. It probably would make a lot of sense to do this with an enum. I think here where it's like literally just one thing,
Yeah.
but that's a good idea. And yeah, you can play around with this. I do want people to explore how we might not hard code this, which I think is really interesting. There's really two approaches there. So you could extract it, like you basically load the token URI and then extract the first part. Or when you instantiate it, you could also set like the base URL. That could be fun. There's lots of possibilities. No right way to do it, really. Anything else?
Hey, Jack, one
Yo,
question.
what's up?
Hey, my branch, so I forked the code, right? 2 weeks ago or something.
Yeah.
And my branch on my repo is messed up. I can't fork it, like I can't sync it because I probably need to like
You
rebase
probably
it.
yeah, you
Yeah.
probably made changes.
Yeah, I did. How
Are
can I?
you also using VS Code?
Yeah, but with WSL and stuff. But yeah, I don't know how to work with two remote, because it's basically like two remotes, right? We have like my remote and then your upstream remote.
Yeah, so this is a really good question. There might be some good Windows tools for Git that might really help that. In fact, if anyone here actually uses Windows and you're familiar with Git, that would probably feel free to chime in here because I've actually not, I kid you not, I've not really had a Windows computer since Windows 98. My knowledge of Windows is like basically zero. But here's how I would do it. On the command line, I hope this is big enough. Let me like,
Yeah, it is
cool. So if you type in get remote, that'll list your remotes. You see I have one called origin. So I'm gonna actually fork the code and show repo to show you how this works. So I'm gonna fork this right now. Cool. So I've made a little fork. Awesome. So this is my fork, right? I'm gonna get my little, I use SSH. I don't know how you have yours set up, but you're basically gonna get that and you're gonna do get remote add. There's probably a UI way to do this too. And then you have to give it a name. So I'm gonna do get remote add mine. And now when I do get remote, I've got mine and origin, okay? Cool.
Okay.
So if you do get remote -- verbose, it'll actually show you the URLs for them. So you try that right now. If origin is set to yours, which it might be, whatever your GitHub username is, that means that, and you want to pull from upstream, you're going to have to add the remote. You're going to have to add code and chill as a remote repository.
Okay.
So you could do that by just grabbing the little GitHub thing. Obviously, I've already have mine set to origin, but let's just say let's pretend that origin in my example pointed to my repo. I would do get remote add upstream, call it upstream, and then boom. And then we look at that. And so then we would see upstream would be Cosmos contracts, code and chill. And
Correct.
that's when we would be able to do git pull -rebase upstream, which would be the Git server. And then we would do the branch, which would be main. I might ask you for your.
Oh yeah, okay. I have some unstitch stuff, so let me revert them.
Yeah, you could also stash it for the time being if you want.
Oh, it worked. Yeah, nice.
Oh yeah. So now you're back in sync.
Nice, yeah. It's still rebasing.
Yeah, I had a lot of pain back in the day with having to learn how to use Git, and I had a very patient person who I worked with really early on when I was like a super noob, and they were like, "Here, dude, let me show you how to use Git." And then I was like, "It's skills for life."
Yeah, nice. Thank you.
Yeah, for sure.
Windows, and you want to use Git as like a beginner, GitHub desktop, the app from GitHub is pretty okay. If you just want to do some like basic collaboration.
Do you mind posting a link?
Yeah, that would be helpful.
Yeah, I'll link it.
And then y'all should try out these this really awesome, this Gitpod stuff because it works pretty great. And then you can just literally just come in here and just click open a Gitpod, do all your coding in a already set up environment. And if you log in with GitHub, you can just push your changes like directly from there as a pull request, which is pretty sick. So yeah. Any other questions before we close? This was another good code and chill. I feel like they get better all the time. And eventually I am going to learn how to use, I swear I'm going to learn how to use VS Code and get less confused and go on less random tangents next time. But definitely check out NFT storage. It's super useful. And they have some really pretty good docs about how to use all this stuff. And you'll learn a lot about this. I guess my challenge for you guys is to like, maybe try to like actually upload this on testnet. Try to give yourself the practice of trying to structure your metadata files and upload them so that you could use them in this dynamic NFT format. And then maybe even the extra challenge would be try to take this code and try to make it more of like maybe a game, or maybe modify it so it's not just like the NFT trees like example. Maybe try to like think of something a little bit more creative and fun. And next week we'll work on, I think, trying to take this in more of a game direction and explore how we could make it a little bit more fun and a little bit more degenerate, because why not? All right, going once on questions. Going twice. I have to get going. My girlfriend has been extremely patient, and this has already gone longer than I said it would. But y'all should keep hanging out here. In fact, we've been hanging out here during the week. So yeah, keep hanging out. And let's see. Andre, congrats. You're now accepted to Lead Society. Send me your address. You are now an apprentice, and you will get access to some really great mentorship and get to hang out in secret channels with Reese and Zeke and Noah and myself and Adair and Dan and some of the best CosmWasm developers out there. And then we're going to build some cool stuff, and you can learn some Juno and ownership of whatever like projects we build. And it's going to be really fun. And for those who are curious about what the hell Lead Society is, it's going to be launching next week. And there is a channel above called hashtag Lead Society or 1337 Society, and has a little bit about it. But basically it is a developer DAO that is organized in a guild structure. So if you're looking for like a shared learning environment, if you're trying to make some friends, maybe do some networking, you want access to some really great opportunities, you want to build a reputation, and you want to earn some funds and maybe get some like cool like NFTs and NFT badges, you should check it out. But like, it's invite only, so the way to join is basically just keep participating in this community. Yeah. Until next time, I look forward to hanging out here more and chatting with more of you as we go. So peace. Later.